Very good. All right. Well, welcome everyone to our Climate Action webinar series on water sustainability design for architects. My name is Deborah Gerard. I am the 2020 president of AIA California. And AIA California, as many of you know, officially kicked off our Climate Action webinar series last month with a 1-hour presentation highlighting the new residential energy code updates. If you missed that, please be sure to check out the Climate Action portion on the AIA California website for the recording, slide deck, and additional helpful resources. We're going to do a webinar every month, and the remaining webinars in this series will be centered around each of the pillars of the AIA National Framework for Design Excellence. Design is not just about aesthetic components, but how buildings perform for people. The Framework for Design Excellence is made up of 10 measures. They were formerly known as the COAT Top 10 Toolkit. It organizes our thinking, facilitates conversations with our clients and the communities we serve, and sets meaningful goals and targets for climate action. So today's webinar will focus on designing for water. And when using this lens while looking at your next project, we're hoping that you're thinking about how does the project use water wisely and handle rainfall responsibly? Sustainable design conserves and improves the quality of water as a precious resource. It illustrates how various water streams flow through the building and the site. And we're hoping that you are learning about major water conservation and stormwater management strategies. We also hope that you're thinking about how the project relates to the regional watershed, and that you'll learn strategies to reduce reliance on municipal water sources. And lastly, how does the project recapture or reuse water? Before I introduce our speaker for today, I just want to give you a few basics on how to ask questions. So there's a Q&A box in the lower or upper portion of your Zoom window, depending on how your window is oriented. So we're recommending that you type in questions for our speaker to answer during the Q&A period. So about our speaker, we are very pleased to have Taylor Chang presenting to us today. Taylor is a water resources analyst at the San Francisco Public Utilities Commission. She manages the Onsite Water Reuse Program, which allows buildings in San Francisco to collect, treat, and reuse water on site for non-potable applications. She focuses on providing technical assistance for developing on-site water reuse projects. Taylor has her undergraduate degree from UC Berkeley in environmental studies and a master's in public administration from the University of San Francisco. Taylor, thank you for being with us. The webinar is yours.
Great, thank you. So just to briefly go over our learning objectives today for the webinar. The first one is to learn about the National Blue Ribbon Commission for Onsite Non-potable Water Systems innovative and collaborative approach to addressing key design, implementation, regulatory, and water quality challenges to on-site water reuse to create consistency across the U.S. The second is exploring the risk-based approach used to develop treatment requirements and monitoring approaches. The third is to learn about a soon to be released, which is actually released now, guidance manual and training modules, which teaches designers, developers, operators, and regulators the knowledge and skills to safely implement decentralized water systems. And then lastly, discover the steps to reduce potable water use and to determine what is really needed. Do we really need to irrigate a lawn, or can we plant self-sufficient natives instead? Do we need to use potable water in our chiller, or can we capture rainfall or collected condensate? So let's get into it. The title of my presentation today is Advancing On-Site Water Reuse and Our Lessons Learned. The San Francisco Public Utilities Commission is a municipal department within the city and county of San Francisco, and we provide 3 utility services to San Francisco. The first is water. So we deliver high quality water to 2.7 million people around the Bay Area. We're both a retail water provider as well as a wholesale water provider. We also generate hydroelectric power, and we provide wastewater services through our combined wastewater and stormwater system to San Francisco. We face a lot of challenges to our future water supply reliability. Focused here on this slide, things like drought. We are always concerned with building resilient infrastructure, and to that vein, a lot of our infrastructure is aging rapidly. We also are challenged with providing new water supplies for the booming new development that's happening here in the city, as well as meeting stormwater management goals, and challenged by some regulatory and stream flow requirements on our water system. How we've thought about dealing with a lot of these challenges is moving towards a one water SF approach. So it's really a shift from the traditional 20th century model of resource management where water supplies come in from the mountains and then go out to the bay as wastewater. One water SF is really thinking about holistically how we can better reuse sources of water on site, how we can integrate things like solar power and biogas generation and resource recovery into our water and wastewater systems, really towards an integrated water management approach. One of the ways that we're implementing One Water SF here in the city is through our local water program. So our local water program is consisted of several different program areas, including water conservation, a groundwater program, recycled water program, Onsite Water Reuse Program, and an innovations program. What I'm going to talk mostly about today is our Onsite Water Reuse Program. And I just wanted to make the distinction that when we talk about our recycled water program, that's really focused on centralized municipal scale recycled water that we're building out on the west side of San Francisco. And on the on-site water reuse is really about these decentralized water treatment systems in buildings to reuse water for non-potable use. So getting into our program implementation for on-site water reuse, buildings generate resources, not waste. Buildings produce a variety of water sources, including rainwater, which is precipitation collected from roofs, stormwater, which is precipitation that's collected at grade, street level, foundation drainage, which is nuisance groundwater that's traditionally pumped to the sewer, but can be actually captured and reused. Graywater, which is wastewater from clothes washers, bathtubs, showers, and bathroom sinks, and as well as blackwater, which is all the wastewater that's produced in a building, including from toilets, dishwashers, kitchen sinks, and utility sinks. So we really see these water sources as a resource that can be reused. We have been pioneering on-site water reuse here at our SFPUC headquarters building. We're in the Civic Center neighborhood, and we moved into this building in 2012. And our organization, to demonstrate our commitment to sustainability, really wanted to showcase some innovative features in our building. And that included this on-site blackwater treatment system. So it uses engineered wetland treatment technologies, as well as filtration and disinfection to treat all of our buildings' wastewater and reuse it for toilet flushing and urinal flushing in our building. And we're able to save about 50% of our potable water use through this on-site treatment system. So like I mentioned, we moved into our building in 2012, and at that time, we used our building on-site treatment system as a test case for how do we allow other buildings in San Francisco that want to do similar applications to do this on-site water treatment and reuse. So in 2012, we passed an ordinance in the city that allowed single individual buildings to capture, treat, and reuse water on site. And in 2013, we recognized that there's economies of scale to these systems where things get more efficient and cost effective when you do it at a district scale or a neighborhood scale. So when we say districts, we are talking about 2 or more buildings that are sharing alternate water sources for non-potable applications. And then in 2015, our ordinance that we put into place became a mandatory requirement for new construction over 250,000 square feet. So in 2015, we were at the height of a drought, and water conservation was a huge thing for the state. And our local board of supervisor, who's now a senator, he at that time put this ordinance into play for mandatory requirement in 2015. And then lastly, in 2019, we've expanded our focus to include things such as innovations and brewery process water reuse, which I'll get into a bit more later in my presentation. So we have a lot of buildings that are either proposing or have installed on-site blackwater treatment systems. I'm going to go through a couple examples here. 181 Fremont is a new mixed-use building in San Francisco. The top third is luxury condos, and the bottom 2/3 is office space. And they've installed a graywater treatment system that's treating both graywater and rainwater to meet toilet flushing and irrigation demands in that building. And the picture on the left-hand side, which is kind of hard to see, but I included it on here because this digital wall display is taken from 181 Fremont's sales office. And so when prospective buyers come into the building to look at the units, they see this display, which is really highlighting the on-site graywater treatment system as a feature, as a green building and sustainable feature of the building. And the reaction that we've heard has been that prospective buyers they think that that this is business as usual. Like, they're not surprised or taken aback, and they're really expecting that buildings in San Francisco have these types of sustainability features. So I thought that was an interesting thing to share. 1500 Mission is a new residential tower that's currently under construction, and they have their on-site treatment system actually just went in, and they're currently hooking everything up. But that system is going to be treating graywater and rainwater for toilet flushing and irrigation as well, saving about 2.5 million gallons of potable water each year. The Salesforce Tower, I think many people know, is the largest building west of the Mississippi. And you can see it everywhere on our skyline. And they were actually, on a voluntary basis, are installing a blackwater treatment system to meet their non-potable demands for toilet flushing, cooling, and irrigation. Moscone Convention Center is our big convention center in downtown. They are operating currently a foundation drainage system where they are, previous to this project being constructed, they had millions and millions of gallons of foundation drainage or nuisance groundwater just flowing to the sewer system every day. And so they thought, during their expansion, why don't we build a project that's going to capture that foundation drainage and reuse it in the building. And so now they're flushing over 200 toilets in the convention center, as well as some irrigation. And they built, the picture on the right is a street sweeping truck fill station. So our public works trucks will come up and pull up to the side of the street, and they turn on this pipe, and the treated foundation drainage is then used to clean the streets of downtown San Francisco. The Chase Center is a new sports arena that was just built here, and they were required to put in an on-site treatment system, and to comply with that ordinance, they are installing a rainwater, stormwater, graywater, and condensate capture treatment system for toilet flushing in the arena, as well as the 2 accompanying office towers featured in the photo. Getting to some of our lessons learned. This is just to summarize what I'm going to get into detail right now. We have a lot of lessons learned around water quality and treatment design. We have some key utility lessons learned that we've learned over time, lessons learned around operator capacity, examples of how we partner with developers and designers and the public around these systems, and then some opportunities for resource recovery. One of the things that we've learned about our program is we require all on-site water treatment systems to be connected to our municipal water and sewer systems. So we do not allow any off-the-grid type systems where there's no connections. We require all of those systems to be connected because, for example, if your treatment system, if one of your parts needs to be replaced or there needs to be maintenance on your treatment system, you need a way to serve your toilets, for example, with water for toilet flushing. And so you really need a backup municipal water connection to be able to protect public health in these buildings. As well as if there's an issue with your water quality in your system, you need to be able to divert that water to sewer, as well as meeting your toilet flushing needs. We also have backflow protection requirements and cross-connection testing requirements. And these are really requirements to protect our municipal water system. So we require buildings that have these on-site treatment systems to do a full cross-connection shutdown test prior to operation. So what that means is that you basically shut down your potable water system connection to your building and you power up your non-potable connection, and then vice versa to make sure that all the fixtures are hooked up as they should be. Other water quality lessons learned that we've had, looking to the California Plumbing Code, there's limitations in what the code allows. And so it does cover graywater and rainwater reuse, but there's really no oversight and management that's required of these systems from the plumbing code, as well as it relies on standards such as NSF 350, which really are not health risk-based standards. And what we found in our work and with our national work as well is that really the best protection of public health is to have these systems meeting water quality standards that are based on a risk-based approach. And that really means designing these treatment systems to reduce pathogens that can impact public health. And those pathogens of concern include protozoa, bacteria, and virus. And the image on the right is really to just show that this approach is really fit for purpose. So we're defining water quality standards really based on the type of water that you're capturing and what you're trying to use it for. Graywater and blackwater treatment. So we have learned that biological treatment of graywater and blackwater is really effective at reducing organics in the water. And those are the types of things that can, impact the aesthetics of the water. So like odor and smell, for example. So biological treatment of graywater and blackwater can really help to reduce total suspended solids, turbidity, BOD. It can improve UV transmittance, and it can also help reduce ammonia. One of the interesting facts that we've learned about graywater and blackwater treatment is that graywater, the incoming biological oxygen demand, or BOD, in that water can be quite high. And that's not something that we traditionally have thought that would be that high, because what typically causes high BOD is found in blackwater. So that was a really interesting fact, and we've modified our program to actually require that biological treatment to really bring those high BOD levels in graywater down. And then the last point is really that aesthetics are an important consideration for graywater and blackwater treatment in terms of how it looks, the clarity of the water, and the odor. Specifically to rainwater harvesting systems, we have a number of rainwater systems operational here in San Francisco, and some of the lessons learned include, excuse me, to avoid routing rainwater through a green roof or a planter, because that can create issues with color and turbidity downstream, which can impact your treatment. Another one, for example, we've also seen is that tanks and pipes have to be properly sealed to prevent mosquito growth. And then lastly, thinking about plumbing your rainwater capture cistern to be able to flush with potable water helps avoid dry season stagnation and really just keeps that tank not go stagnant. Moving on to our utility considerations and lessons learned. We have heard from a number of utilities across the country and across the state that wastewater flows and odors are a concern. So what happens when you're reducing these flows to the sewers by reusing water on site? And how we have dealt with that here in our utility is that so our utility has a water utility and wastewater utility, and we work with our wastewater department really to conduct hydraulic modeling. And the hydraulic modeling is really looking at, are there actual impacts to wastewater flows and odors? And we've run that on all of the projects that have come in for approval from the city. So far, we have seen no impacts that are expected in the city. However, if there are expected to be impacts to flows and odors, we provide alternative strategies to projects to deal with those potential impacts. And that can include flushing of the sewer laterals, as well as instead of discharging solids to the sewer system, actually having trucking, a Vector truck come and pump away that sludge and take it away to the wastewater treatment plant. Some of the other things that we've learned include capacity charge adjustments. So we charge a one-time capacity charge fee to hook up to our municipal water and sewer systems. And we recognize that buildings that have these on-site systems are not using 100% capacity of our municipal infrastructure. And so we give capacity charge adjustments to projects with these on-site systems, and that can be pretty significant financial savings, $30,000, for example. And then our excess use charges is really on the opposite side of the scale. It's really the utility's enforcement mechanism to make sure that projects that are required to put in these on-site treatment systems are not just installing it and then turning it off and walking away after day one. So the excess use charges are a financial penalty that we put onto projects by assigning them a water budget, saying you have to, you said you were going to put in this on-site system and produce this much water, and if you don't produce this much water, we're going to charge you excess use charges on your water and sewer bills. Operator capacity is a fun topic. We have learned that these on-site treatment systems really need capable and well-qualified operators. And one of the things we found is that these on-site treatment systems really are combine technologies from both the water and the wastewater side. So an operator that has experience in both of these water and wastewater technologies will really thrive in this environment. For our program in San Francisco, we require operators to sign an affidavit acknowledging that they have the appropriate knowledge, skills, and training to be able to run the treatment system. And then lastly, early communication is really key among operators, project owners, engineers about ongoing O&M costs and responsibilities. We've developed a number of tools, technical and financial assistance tools to help our design and development community understand what the requirements are and how to navigate the process. The image on the top left is a screenshot of our calculator. So we have a free calculator on our website that really helps buildings understand how much graywater and blackwater and rainwater supplies that a building of whatever square footage you enter in can produce, and what are the demands, estimated demands for that type of building. And we also have a guidebook that we've produced that really is a technical resource to help distill down the requirements of our program. And then we also have a grant program. So we provide financial assistance to projects that are either voluntarily installing these systems, or if they're a mandatory project, if they can demonstrate water savings above and beyond what they're required to do by the ordinance, we provide grant funding for those projects. So that actually ranges up to $1 million, depending on how much water you can demonstrate that you're saving. One of the lessons learned that we share with designers and developers, just a very short example, is that encouraging blackwater reuse in commercial buildings as opposed to graywater can significantly achieve higher potable water savings. And this is really because commercial buildings don't produce a lot of graywater. So really the only graywater in a commercial building is coming from hand sinks. And that doesn't really, you can't really get a lot of water savings from just capturing that small volume of water. So we encourage commercial office buildings to think about incorporating blackwater treatment systems, because you can get a lot more flow from capturing all of the wastewater in your building. Additionally, signage in bathrooms and common areas is a great opportunity to engage with your building occupants and visitors about the value of water and about the value of conserving water with an on-site treatment system. So while there are specific requirements around signage and what you have to say on signs, there's a way to phrase them, we've found, that is really more about educating the public and engaging with them. So this picture actually is from our building's signage that we have near our wetland treatment system that says, "To conserve water, this planter is part of our on-site water reuse treatment system, not for drinking." Another thing we've learned about and really are interested in tackling is the water energy nexus around these on-site treatment systems. We are very interested in wastewater heat recovery, defined on the slide as the extraction of thermal energy from warm wastewater and subsequent beneficial use of this energy to offset building energy use for applications such as hot water heating or space heating or cooling. And so these wastewater heat recovery systems can actually be integrated with on-site reuse to offset some or all of the energy needed for the on-site water treatment. Maximizing the benefits of wastewater heat recovery really requires integration with the building's hot water and or space heating and cooling systems. So something to think about at the very beginning of your project when you're designing these, when you're designing your building's infrastructure, is to think about that. And then, as I mentioned before, we have a grant program where we provide financial incentives. And to encourage wastewater heat recovery, we are saying that all projects applying for a grant are required to estimate the potential energy offset that can be achieved with wastewater heat recovery. And as well as if you're a mixed use and multifamily building applying for a grant, you are actually required to implement wastewater heat recovery. So switching gears a little bit to our innovations program. As I mentioned earlier in my presentation, we are really interested in brewery process water reuse. We recognize that breweries are a significant water user in the city. A typical brewery can use 5 to 7 gallons of water to produce 1 gallon of beer. So that's pretty significant. And we also recognize that there is an opportunity there for on-site water treatment of processed water. So processed water is really the water that's used for cleaning in the breweries. So that can include rinsing tanks, rinsing bottles and kegs, floor wash down. And so those types of water sources are called processed water, and they can actually be captured and treated and reused for similar applications, as well as potentially putting it into the beer itself. And so our on-site water reuse program incorporated some guidance for breweries that are interested in doing processed water reuse and how to do that in a manner that protects public health. And so in our grant program, we developed a chemical and pathogen control strategy that's really based on these 4 key elements highlighted on this slide to ensure protection of public health. So those components include source characterization, source control, treatment, and ongoing monitoring. And this scheme chemical and pathogen control strategy is really to help breweries and provide guidance on using that processed water for cleaning applications, as well as a source water for the beer itself. Another part of our innovations program is our Pure Water SF project. This project actually just wrapped up, and the purpose of this project was really to research and understand what it would take to do direct potable reuse at the building scale. And so we were kind of in a unique position because we have this on-site water treatment system, the living machine, in our building. And so we wanted to do some research to understand how to further treat that water to drinking water standards. We were not making our employees drink this water. It was really just for research, and we were putting all the treated water back into our toilet flushing system. And so this project was really about building on our legacy of innovation. It was about researching how well these advanced treatment processes work, and as well as researching and understanding online monitoring and how that is working with these treatment technologies, and really about exploration and community engagement. We gave weekly tours and are still giving weekly tours to the public and to folks in our building about our water system and about this project. And some of the findings that we've gathered from this research project, we did over 1,300 individual analysis on different water quality parameters. We felt that this project was really successful in terms of the treatment processes achieving all of the pathogen removal goals. We tested and sampled for things like pharmaceuticals and chemicals of emerging concern, and was demonstrated really effective treatment of those pharmaceuticals and CECs. So you can see that from the graph here included on the slide. Another portion of our innovations program is focusing on atmospheric water generation. So this is just another opportunity that we're looking at to produce water on site. These two examples on the slide are really interesting. This one on the right-hand side, the Hanger One Fog Point Vodka. So that's a local distillery here in the Bay Area, and they installed these fog catcher mesh nets up at Sutro Tower, and they captured fog up there, and then they used that to produce this limited edition Fog Point vodka. And then the image on the left is a atmospheric water generation technology that uses solar power to extract water from the air. And the Denver Botanical Garden has piloted this technology, and they're using it for irrigation of these planter boxes that grow herbs for the restaurant on site. So these atmospheric water generation is an area that we're currently studying and pursuing a project to put in these types of technologies and test the viability of producing water for irrigation in a community garden, while we do some testing to understand the water qualities that these systems are producing. So again, switching gears a little bit now to our collaborations on a national level. The San Francisco PUC has been leading a group of water and wastewater utilities and public health regulators from across the country since 2014, really coming together to understand what are the barriers to on-site reuse and how can we address those from a public agency perspective. So in 2016, our group was formalized into the National Blue Ribbon Commission for On-Site Non-potable Water Systems, really to, again, address what are the key barriers to implementation of on-site reuse and addressing these key issues here. So creating consistent water quality standards from state to state, promoting this risk-based water quality approach, encouraging local and state oversight and management programs for on-site systems, and really serving as a forum for peer-to-peer learning and exchange from a regulatory and utility perspective. When we started our work as a national collaborative, we really were trying to understand one of the key barriers, which was what are the appropriate water quality standards for these on-site systems. And the point of this slide is really to show that when we were looking out into the world and to the country at plumbing codes and at water codes, it varied so much from state to state, and there was no consistency at all. And so what we decided to do was to put together an independent expert panel of water quality specialists to really address this issue: what is the appropriate water quality standard for decentralized on-site treatment systems? And what came out of that process was this report. And this report really laid the foundation for the risk-based water quality approach. And so it established pathogen log reduction targets for virus, protozoa, and bacteria. It established continuous online monitoring regimes, and really led to treated water quality standards from a risk-based perspective. So what exactly are pathogen log reduction targets? Pathogen log reduction targets are really a way to it's based on a risk assessment based on the type of water that you're treating, so your source water, and what you're trying to use it for. And so all source waters have a different starting pathogen concentration. Intuitively, you can think about higher pathogen content in blackwater than in rainwater, for example. And then the target safe pathogen level is the same regardless of your source water. So you're getting the same level of protection regardless of what type of water you're using. And this is really, again, about the fit-for-purpose approach for non-potable end uses and creating a standard that matches the right source to the right use in terms of water quality. This is the table of the water quality standards that came out of that report. For the various sources and end uses. So the way you use this table is to look at what type of water source am I capturing. So if I'm capturing blackwater, for example, and I want to use it for indoor toilet flushing, I would go to the line that says blackwater indoor use. And so I would have to meet an 8.5 log reduction of virus, a 7 log reduction of protozoa, and a 6 log reduction of bacteria. And this methodology is not a new methodology. It's been widely used and accepted in potable reuse and drinking water schemes. It had just never been applied to this decentralized non-potable water systems before. So how do you get from that log reduction, pathogen log reduction target to an actual design of a treatment system? And this is an example of how you would do that. So this example is just Graywater for toilet flushing. And so what you do is you have your treatment processes. You choose and select treatment processes that can meet certain pathogen credits based on how you operate the treatment technology and how you incorporate online monitoring with those technologies. So for example, a UV with a validated UV reactor, and if you're monitoring things like UV intensity, you can get credits, up to 6 credits for that UV reactor. And each treatment technology in your treatment train are assigned credits. And these credits ultimately add up to your requirement for your log reduction target for your each pathogen classification, virus, protozoa, and bacteria. This risk-based pathogen log reduction target approach is really being adopted across the country. San Francisco has obviously adopted this risk-based approach. When the report came out in 2017, we modified our program to incorporate the standards. Colorado, the state of Colorado, has already amended their Regulation 84 to incorporate the risk-based standards for blackwater treatment systems. The state of California itself, as well as Hawaii, have both passed state legislation to have the risk-based standards incorporated on a statewide level. And Minnesota and Washington, D.C. have published guidelines for stormwater that incorporate the risk-based standards. Washington State and Oregon proposed legislation that's moving forward, to my knowledge, that incorporates statewide risk-based water quality standards, as well as Texas and Alaska that are considering similar steps forward. So all of these states and jurisdictions are part of our Blue Ribbon Commission work that's really, you know, gearing towards consistency from state to state. Just to give a quick timeline update for folks that are interested in where these regulations are going in California, that bill that I referenced on the last slide, SB 966, directed the State Water Board to develop statewide risk-based water quality standards for these systems by 2022. So the state shared their timeline with us recently. They're putting together an advisory panel in July of this year. Later this year in fall and into late spring 2021, they're going to be doing general stakeholder outreach to the public. And then they're going to begin the rulemaking process in 2021 to hopefully wrap that up within a year by the end of 2022. So just a little preview of what's to come for the state regulations. And then what I talked about as one of the learning objectives was this guidance manual that the National Blue Ribbon Commission just recently finished. And this guidance manual includes a manual, PDF manual, as well as PowerPoint modules on each of these different chapters. And so it's really meant to address key learning objectives for design engineers, operators, regulators, program administrators, and system owners. What can you expect to find in this guidance manual? So it goes into a lot of detail, very clearly and simply on explaining risk-based water quality standards, the basis, the technical basis for coming up with the log reduction targets, as well as these pathogen crediting frameworks that are used to develop the credits for the treatment technologies to meet the log reduction targets. So again, it discusses an overview and detailed discussion of pathogen crediting. It discusses how existing crediting frameworks can streamline its implementation. And the emphasis is really on online real-time monitoring. In addition, it includes a whole host of examples of example treatment trains. So like I showed you a few slides back, this is an example of a blackwater treatment train, and it really breaks down what the types of online monitoring that you need to do for the treatment processes, how you can get those credits, and what it all tallies up to in terms of the total log removal. The guidance manual also includes stakeholder-specific tips and key messages. So one of the ones that we just pulled out for this slide includes the design engineer should evaluate source water quality to determine the size or combination of sizes of pre-treatment screen to select. So this is really highlighting the importance of understanding what the quality of your source water is, which will then impact your treatment design downstream. And then the other example stakeholder tip that we provided was successful implementation of the operations plan will require that the necessary resources, such as personnel, training funds, and information are available. It includes commissioning and operations guidance. So it includes things like a commissioning plan checklist, as well as the types of alarms that designers and system operators should be aware of in these systems. It includes example guidance about a regulatory framework. So if you're not doing a project in San Francisco, what a program and regulatory framework could look like, and both from the regulatory perspective as well as from the project team perspective, in terms of like the documents that you're going to be requested to submit. And then, you know, we have a lot of research priorities that we are hoping to accomplish. Our work is not done, and that really is to think about expanding our risk-based framework to address other types of water sources that were not currently in the table. So, for example, condensate, as well as end uses such as cooling, tower makeup. We're also invested in developing a on-site water system operator certificate or certification program. And then, looking to do more research into developing crediting frameworks for commonly used treatment processes and on-site systems. This is my last slide, so I'm really going to wrap up here. I think the main points that I really wanted to highlight were that the consensus that the Blue Ribbon Commission has been building among states is to move towards this risk-based approach. Secondly, we really have an opportunity to establish a new water paradigm in the urban environment. These on-site water treatment systems are really transforming how we view and how we think about our connection to water. And when you add on additional resource recovery components, such as wastewater heat recovery, it's a shift in thinking about managing our resources differently. And then, it's led to opportunities to share our lessons learned here in San Francisco, both with you all, as well as on the national and global stage. And then, lastly, some of the things that we are pursuing in terms of future activities include pursuing funding for the research items that I mentioned on my previous slide, thinking and working with our plumbing code folks, so IAPMO, for example, on how we can align the plumbing codes with these water quality standards, and as well as partnering with NSF, because NSF has their NSF 350 standard for graywater systems, so how can we align NSF with this risk-based water quality approach? And then also working with U.S. Green Building Council and the lead teams to think about piloting additional credits that really recognize all forms of water reuse, including decentralized treatment systems and centralized non-potable treatment systems. So with that, I will conclude. There's my email address if anybody wants to get in touch with me, as well as some website links for more information.
Well, that was excellent, Taylor. Thank you so much. We've got about 8 questions waiting in the wings for you. Before we go to those questions, I am going to ask any of you attendees who are signed on with a larger group, such as I know is happening at my firm of Gruen Associates, if you guys can just send an email to us, send a comment to us and let us know about how many people you have participating. We'd be interested in that. So please do so. Thank you for that in advance. And so Taylor, do you want to just start at the top here with these questions and take them in the order they were sent in?
Sure. I'm going to pull them up. Just a minute.
Or I can read them off to you if that is better, easier.
Nope, I got them right here. Okay, the first.
Okay.
First question is, how does the old sewer infrastructure work with less water going into the system? Most old sewers back up without adequate water flow, especially since they are built with a shallower drop. So yeah, I mean, I touched on this a little bit on my utility considerations slide. One of the things that we do is this hydraulic modeling and hydraulic analysis. And so what the hydraulic analysis does is that it takes a look at the existing conditions. So for example, if it's like a vacant lot, it looks at that, and then it looks at the proposed development that's being proposed for that site. And it looks at the connections to our sewer mains and sewer laterals, and it spits out an analysis basically of, is there going to be an impact to our odor and our flows, and it takes into account existing conditions. If we have problem areas in the city where there already are existing odor issues or flow issues, takes all of that into account and really does a site-specific analysis for each treatment system that's being proposed. The next question, many municipalities are prohibiting the use of natural gas. My hypothesis is that this is very short-sighted and ignores the possible recycling of the products of combustion of natural gas, CO2, and water vapor for the use of green plants. Please comment on how San Francisco can address this. That's a good question, and actually natural gas is not my area of expertise, but I know that San Francisco is in fact moving towards prohibiting the use of natural gas. We have an ordinance, I think, that's changing our green building code in the interim for municipal buildings for all electrification of new development of municipal facilities. So other than that, I can't really comment on that question. Are there published and regularly updated standards we can refer to when making decisions about gray water use in buildings with higher risk for generation or susceptibility? For example, I have had healthcare clients veto gray water use in courtyards. So again, in San Francisco, we have a whole program where we have established water quality standards for water sources, including gray water reuse. And so the water quality standards were intended to protect public health for specific end uses, including toilet flushing, urinal flushing, irrigation, cooling towers, decorative fountains, things like that. In terms of higher risk, and for example, in healthcare facilities, we do recognize that that it is challenging to put on-site reuse systems in hospitals, for example. And so one of the things that we've thought about doing and are potentially pursuing is to exempt those healthcare facilities from the mandatory requirement to put in these on-site systems. Next question is, how much fog does a location require for the atmospheric water generation? Could it work in Vacaville? So that's a good question. There's different types of technologies for atmospheric water generation. And so the example that I had provided with the fog catchers, those require pretty high levels of fog. And it also requires the fog net to be in a high elevation. So those are pretty site-specific types of technologies. There are other types of technologies like the solar-powered AWG system that I mentioned as well that don't require fog at all. And really, it uses solar power to condense water from the air, regardless of really the humidity that's present in the air. And so that company that installs those AWG solar panels, they have them in Tucson, Arizona, for example, where you wouldn't think that there would be a lot of fog or humidity in the air. So there's a lot of different types of AWG technologies that can work in places that don't actually have fog. The next question, on the log reduction target table, why was the roof rainwater NA for blackwater and graywater? Just to clarify, there are log reduction targets for blackwater and graywater for the 3 different pathogen categories: protozoa, virus, bacteria. And there was an NA on virus and protozoa for rainwater because when the independent expert panel was coming up with that table, there wasn't enough data to understand and really characterize the pathogen concentrations in rainwater. And so that's why there was an NA for those specific ones for rainwater. The next question, what happens to all the material removed from the water? So in a blackwater treatment system, for example, there is stuff in the water, so like toilet paper and solids and things like that. And so the solids management strategies are really different for for every jurisdiction in San Francisco. What happens with these systems is that they're all connected to our sewer system. And so as the water gets treated, the solids in the wastewater are pumped to the sewer system. So that's the preferred method. I think for us, there are alternatives that I had mentioned. If there are pre-existing odor and flow conditions in the sewer system where it's trying to discharge, and that can include trucking. So a Vector truck could come and pump out the sludge and the solids from your collection tank and then take that to our wastewater treatment plant. So those are just some examples.
I think we have one more question here.
Yeah, okay. Last question is, for a small town, 40,000 people, does requiring water recycling make sense, especially considering the growth of ultra low flow fixtures? You know, that's a really good question. And, you know, we always say that it's all based on local context. So what works for San Francisco may not work for every community in California. A lot of communities are investing in centralized water recycling. And so that may not make sense to have a bunch of decentralized treatment facilities in your community. So really it depends on your town and your community, and what the priorities are and what investments have already been made and what your water planning and strategies and approaches are for your region.
All right, well, thank you, Taylor, and you were very prompt, and we're finishing right on time. I appreciate that. So a big round of applause, even though she won't be able to hear it, for Taylor Chang for a really great and informative presentation. This will be posted on the AIA California website, and more information is there as well at www.aiacalifornia.org/climate-action. And you can find it there. If you have any trouble, send in a note to AIA California staff and they'll help take care of you. Again, just a reminder, our next webinar will be focused on designing for integration and will take place on Thursday, March 26th at noon. And as always, these are free and a service of AIA California. Thank you all for participating. Bye-bye.